Okay, solving multi-step equations. First thing I want you to do is to take a minute and write down these strategies and then come back to the video. Okay, so some of these are pretty self-explanatory. Drawing a diagram, guess and check we've done before. Using a graph we will be doing later on in the year. But some of these others can also be things that we are doing. Sometimes you want to work backwards. Sometimes making a model similar to a diagram. Check for hidden assumptions. Sometimes they don't give you all the information, but they assume that you know something. For example, they might assume that you know that 12 inches is in a foot. We've talked about this before, relating it to your life and things that you may have already done that are similar to the problem. Eliminating possibilities. Are you sure that that is not the answer or not the way to go about it? Looking for patterns. Sometimes you can see a pattern in the number. Acting it out. Not sure about that one. Listing possibilities, identifying sub-goals. Sometimes you have to solve one little part before you can solve the whole thing. So we'll talk about some of these, and let's actually look at one of them right now. So copy this down. After cashing her paycheck, Tara paid her father the $20 she borrowed. She then spent half of the remaining money on a concert ticket. She bought, bought lunch for $4.35 and had $10.55 left. What was the amount of her paycheck? This seems like a good one that I could work backwards on. So she started with $10.55 at the end. She ended with $10.55. We know she bought lunch, so if I add that back in, now I know that she had $14.90 before she bought her concert ticket. Well, if she had spent half of what she had on a concert ticket, and this is what she had left, before she bought the ticket, she had twice as much. So she had $29.80 before she bought the ticket. She paid her father $20, so therefore her paycheck must have been $49.80. So that's one method of looking at something, working backwards through the problem. Okay? Let's look at some others. So simple multi-step equations. When you're doing a multi-step equation, you want to use the order of operations in reverse to undo the problem. So when we're undoing a problem or solving a problem, we're going to do our addition and subtraction first, then our multiplication and division, then we're going to take care of any exponents or, well, the parentheses is still something that we work with first, but we're going to start with our add and subtract. So first thing to do is to isolate the variable term, and the last thing is to isolate the variable to solve. So for example, if we have 3x plus 7 equals 12, we started with some number x and we multiplied it by 3, then we added 7 to it, and we got 12. So if I want to get back to the x, I need to isolate the variable term by first subtracting. So I'm going to undo the subtraction. 3x equals, 12 minus 7 is 5. So if 3 times x is 5, then if I divide both sides by 3, I will find my final answer. So think of it this way. I started with an x. The first thing I did was multiplied it by 3. Then I added 7 to it, and I got 12. So to undo it, I'm going to undo the last thing first. The add 7 goes first. The divided by comes second, and then I get my solution. We isolate the variable expression first, and then isolate the variable. All right, so here's 3 problems. Turn off the video, try them. You should be pretty familiar with this, and then come back and we'll do them together. Okay, so the first thing I'm going to undo is the addition. 7x equals negative 21, subtracted 13 from both sides, divide by 7. For this one, here's my variable term. I'm going to subtract the 2 first. Then I'm going to multiply by 8, and x equals 40. Remember, this is a parentheses, so the first thing I'm going to undo here is the division. Multiply both sides by 9, and then add 15. Negative 54 plus 15 is negative 39. Yeah, okay, because we're going to add 15 to it. All right, so multi-step equations. You guys have done these over and over. The new type of problem that we're going to look at today is consecutive integers. So integers like 4, 5, 6, 23, 24, 25, those are consecutive. They come right after each other. And we represent them by picking x for our first integer, x plus 1 would be the next one, x plus 2 would be the one after that. What if we want consecutive odd integers like 1, 3, 5, 7, 9? So again, we're going to define x as the first odd integer, then the next one would be 2 more, 1 plus 2 is 3. Oops, that should have said 4. The next one is x plus 4, 1 plus 4 is 5, etc., etc. We can do the same thing with even integers. We're just going to use x as the first even. The next one will be x plus 2, x plus 4. Okay, so again, I know that I go through these quickly, so you should be pausing and writing this down. If you have any questions about this, be sure to ask me in class. All right, so let's try one. Find 3 consecutive even integers whose sum is negative 42. So the first thing I have to do is say that x is going to be the smallest of the even integers that I want to find. So I need 3 of them. So if x is the smallest one, my next ones will be, x is the first one, x plus 2 will be the next biggest, and x plus 4. And I want to add these up to get negative 42. So I'm going to write x plus 2 plus x plus 4 equals negative 42. All right, so combining like terms, x plus x plus x go together, the 2 plus 4 to go together. So 3x plus 6 equals negative 42. Subtract 6 and divide by x. So negative 16 should be the smallest. Let's check it out. So if x equals negative 16, x plus 2 would equal negative 14, and x plus 4 would equal negative 12. If I add those together, they're all negative, so I can add them up and keep it negative, and I do in fact get negative 42. All right, most of this should be review. We'll talk a little bit about some other strategies of word problems, and the consecutive integers is a new idea. All right, that's it.